Welcome to my Learn Easy Maths channel. As in this previous 2 days, we have been discussing about the topic of arithmetic progression, and we have tried to discuss many more things related to the arithmetic progression yesterday and day before yesterday. Today, I am going to just solve very few problems which are having some technicality and skill in solving the arithmetic progression. Now coming to this problem, without any further delay, here is a question: how many three-digit numbers are divisible by 7? Three-digit number means what? We are having 1 to 9 the first the single digit, and 10 to 99 the double digit, and 100 to 999 is 3 digits. So the first least 3 digits is 100. Okay, 100 is divisible by 7? No. 101 is divisible by 7? No way. 102 is divisible by 7? It's also not possible. And 103 is divisible by 7? No. 104 is divisible by 7? No way. 105 is divisible by 7? Yes. Why? Because the unit place of this number is 5. See that 105, when we take 7 ones are, we divide 7 one times and it subtracts from the 10, we get 3, and 3 and 5 is the multiple. 7 5s are 35. Therefore our first 3-digit number which are divisible by 7 is 105. We say that it is a, the first term. Now the last, that is the biggest 3-digit number is 999. Okay, 999 and 998, 997 and 996 and 995 and 994. Okay, let's we test it. 994. What happens? 994. This is 7 ones are 7, 2, 7 fours are 28, 1. Carry out this 14, 7 twos are 14. Yes, this is divisible by 7. Now actually it is divisible by 7 means what? The difference between each consecutive terms will be the 7. So 994, if you add 7 now the next number will be 1001. So therefore 994 is the last 3-digit number which is divisible by 7. Now I take it as 994. It is a multiple of 7 or divisible by 7. The next number is 112. The next number is 119, and so on. So therefore A is 105. AN is what? 994, isn't it? So make a list what is given and what is not given. A is given 105 and AN is given 994. N we have to find, and D will be the 7. As D is the 7, the common difference. What should we do? First we have to write the AN formula. Okay, what is AN? AN is equal to A plus N minus 1 into D. Don't forget, it is very important. AN is equal to A plus N minus 1 into D. What is AN? We have 994 is equal to, because the last term, we assume it is last term, divisible by 7, 3-digit number. And the first term is, the first 3-digit number divisible by 7 is 105. N we don't know, which is to be determined, and D we know that it is 7. Alright. This is simple manipulated simplification. 994 is equal to 105 plus, multiply inside and outside the bracket. 7 into N is 7N, 7 ones are 7. 994 is equal to, the right side is 105 minus 7 is how much? It is 98 plus 7N. Alright. 994 minus 98 is equal to 7N. Okay, This is unit place of 4. Borrow 1. 14 minus 8 is 6. This is 8. 18 minus 9 is what? 9. And what about this? This is 896. Once again, 14 minus 8 is 6. And it is 8. Borrow 1. 18 minus 9 is 9. And this is 896 is equal to 7n. Now, 7n is equal to 896. 896. Therefore, n is equal to 896 divided by 7. Now, n is equal to, this is 7 ones are, out of 8, 7 goes, it will be 19. Then it is 7 twos are 14, out of 19, 14 goes, it will be a 5 comes join. 7 eights are 56. Therefore, n is equal to 128. There are 128 3-digit number between 100 to 999 which are divisible by 7. I hope this will be the best way that we can solve it and we can find out. Similarly, there are many numbers are there. Either it is a multiple or it is a divisible. We have to find in the same way. One important technique I would like to share with you here is, which are the number divisible by 7? Which are the number divisible by 7? What is the true test for divisibility of 7? As I told you in my previous test also, the divisibility rule, I discussed this, that what is the rule or what is the test for the divisibility of the 7. Because in our syllabus books, we have so many divisibility tests like 2, 3, 4, 5, 6, and directly we have 8, 9 and 10 and 11. We don't have any further divisibility test. But I would like to share with you this divisibility by 7. See that one. 994, and we should test it that 994 is divisible by 7 or not. The rule says that take out its unit place. Yes, we have taken it. Multiply or double it, then it is 8. And subtract on doubling or multiplying the unit with the rest of the number. 99 is the rest of the number when we taken the 4 out. And subtract this one. And 9 minus 8 is 1. And 9 is the number. 91. 91 is divisible by 7 or not? Yes, definitely it is. 13 sevens are divisible by 7. Yes. Next, I would take that 996, say for an example. I don't want to take consecutive number because obviously now that 995 is divisible by 7, its consecutive cannot be divisible by 7. So I have taken 996. And as per the rule, I told you just take the last unit number and double it, it will be 12. And subtract this 12 from the rest of the number, that is 99 is the rest of the number, and minus 12. 9 minus 2 is 7 and 9 minus 1 is 8. Then you divide with 7. 7 ones are 7. It is 7 twos are 14. It's not divisible as the remainder will be 3. So therefore, the test, now next number is, I would like to say that 994 plus 7 is 1001. Am I correct? 1001. So take the last number and double it. Thereafter, then take 100, rest of the number, subtract this. From this, it will be 8 and it will be 9. So divide with 7. 7 ones are 7. Okay, 7 ones are 7 and it is 28. 7 for the 28. This is the divisibility test by 7. I hope and you enjoyed this one. Okay friends, now see here, I have taken another question, an example for you, that here there are two progressions are given, 2 APs are given. One AP is 63, 65, 67, etc. Another AP is 3, 10, 17. The question is asked for what values of n for both the APs, both the arithmetic progression, for what values of n are the nth term of APs. The nth term of two APs are equal. This AP AN and this AP is AN, both are equal. What should we do now? Let's First find out the first term. A is equal to 63, D is equal to 2. And for this AP, A is equal to 3 and D is equal to 7. I would say that this AN and this AN will be the same. AN1 is equal to AN2 and N1 is equal to N2. Therefore, AN is equal to A plus N minus 1 into D. And for this one, A plus N minus 1 into D. These both are equal. AN1 minus AN1 is equal to AN2. Right. Then this first AN, 63 plus N minus 1 into, what is the difference? 65 minus 3 is 2, which is equal to, this one will be 3 plus N minus 1 into, what is this called difference? It is a 7. Now, as I told you that the nth term of both the APs are equal, but we should find that what that equal term for both the APs. Now 63 plus 2n is 2n minus 2 is equal to 3 plus 7n is 7n minus 7. Now 63 minus 2, I just subtract 63 minus 2 will be 61 plus 2n is equal to 3 minus 7 is minus 4 plus 7n. Alright. See that I take constant to one side and take the variable to another one. So I will take here 61. This minus 4 will be to the left side being transposed 7n and plus 2n is transposed to the right side, it is minus 2n. 61 plus 4, it is 65 is equal to 7n minus 2n, it is 5n. Okay, 63 plus 2n minus 2, 63 minus 2 will be 61, 3 plus 7n minus 7, 3 minus 7 will be, it is a minus 4 plus 7. I have taken the constant to one side and the variable to another side. So 61 plus 4 is 5, 65, 7n minus 2, n is 5n. Therefore, what about? We want the n. N is equal to 65 divided by 5. 5 ones are 5 13s are. N is equal to 13. A13 will be the same for both the APs. Now you just find out that. A13 is equal to A13. Okay. This is AP1 is equal to AP2 of this A13 are equal. What is AP1? 63, 65, 67. Now A plus 12D is equal to A plus 12D. Alright. What is the first term? 63 plus 12. What is the difference of the first AP? It is a 2 is equal to, what is the first term here is 3 plus 12. And what is the difference of the second AP is 7. Difference means what? Common difference. Understand, don't confuse it. And 63 plus 12 2s are 24 is equal to 3 plus 12 7s are 84. Am I correct? 7 12 7s are 84. 63 plus 24 is how much? It is 87. Now 3 plus 84 is how much? It is 87. Therefore AN is equal to AN for both the AP1 and AP2. Okay, this is the way that how we discussed and solved the problems. Now I am going to just little bit introduce. Okay, now we have a little introductory part of AS, arithmetic series. What is series? Arithmetic series. See that we know that the arithmetic progression A plus D, A plus 2D, A plus 3D, etc. The last term is A plus N minus 1 into D. Okay. These are the terms. First term, second term, third term, fourth term and nth term. No, I want to make a sum of all these. The summation, that is sum of all these terms. A plus D plus A plus 2D plus A plus 3D plus etc. plus A plus N minus 1 into D. the sum of all the arithmetic progression that are arranged in orderly with a definite pattern. This is called the arithmetic series. Sum of all the progression of a given numbers. It is called a series. Now, a plus d plus a plus 2d plus etc a plus n minus 1 into d. Okay, we have to find. What I do know, I make a reversible process here. The a is the first term and a plus n minus 1 into d is the last term. Reverse the whole progression and whole series. So write a plus n minus 1 into d is the first term, reversing from last, now from first to last. Now reverse it from last to and proceed on to the first. First to last we have written a plus d, a plus 2d, etc. a plus n minus 1 into d. Now by reversing the series, I am going to start with a plus n minus 1 into d. Then what is the preceding of a plus n minus 1 into d? A plus n minus 2 into d. Okay, n minus 1, its preceding minus 1 is added, minus 2. Then a plus n minus 3 into d, etc. It will be a. It will be a. Lost. Okay. Now this is one sum of the series Sn. This is reversible series, another Sn. Okay. This is the first series, this is the second series. Adding LHS Sn plus Sn, it will be 2Sn. This Sn. Now I have to add it. The first term a and a plus n minus 1 into d. Be careful and just pay the attention very carefully. I am adding the first term of this one and the last term. A plus a is 2a plus n minus 1 into d. Alright. Similarly, this second term a plus d and a plus n minus 2 into d. Yes, because there are no d, n minus 1, there is 1d. So this is a difference of 2d minus 1d is again n minus 1 into d is 2a plus n minus 1 into d. I explain it. Don't afraid of that one that Sir is skipping. I am not skipping. See that n minus 1 into d, here is there is no d. Do you understand? N minus 2 into d, here is 1d. 2d minus 1d is one single d, that is n minus 1. Similarly, okay, a plus n minus 3 into d and a plus 2d, right? Then a plus a is, it will be a 2a plus, okay, n minus 1 is common, you understand. This is 3d minus 2d is what? N minus 1 into d. This is 3d minus 2d, n minus 1 into d. Similarly, last again it is a plus a, 2a plus n minus 1 into d. See, a first term and the last term and second term and before the last term and the third term and next the before the preceding of the before the last term and the last term plus the first term. I hope you understand very clearly. Alright. So 2Sn is equal to 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n minus 1 into d, etc. 2a plus n minus 1 into d. How many terms of 2a plus n minus 1 into d? Children, it is n into 2a plus n minus 1 into d. How many terms we have? Because the first to the last term is, the first term is a and the last term is n. We have added the double series, first to last and last to first. So it is the double 2Sn series. It is n into 2a plus n minus 1 into d. But we want the sum of n term, Sn. We want only Sn. Then 2 comes to the down of the n divided by 2, 2a plus n minus 1 into d. This is the formula for sum to n terms of an AP whose first term is a, common difference is d, and there are totally n terms. N by 2, 2a plus n minus 1 into D. Is it very simple now? So I am going to just modify this little bit in another way. N by 2, split this 2a as a plus a. Alright, split the 2a as a plus n minus 1 into D. What do you find, children? N by 2, alright, this is a, then this a plus n minus 1 into D is nothing but an. Okay, n by 2 into a plus an is an Sn formula. This is also a formula, right? For this one, I am going to take an illustration. Okay, don't just move away from the video. Only very little and last duration of this video is remaining. So I am going to show you this literally in an example by taking some problems. See this one. 2 plus 5 plus 8 plus 11 plus 14 plus 17. Okay. 2 plus 3 5, 5 plus 3 8, 8 plus 3 11, 11 plus 3 14, 14. This is about series. Because it is an arithmetic progression, I have added in a series way. Now reverse this one. The last term will come down to the first term. 17 plus 14 plus and 11 plus, okay, then what it is, 8 plus and it is 5 plus and it is 2 plus. Okay, this is Sn one form, this is an Sn and another form. 2 plus 5 plus 8 plus 11 plus 14 plus 17. Reverse the order how I have reversed here, taking the last term to the first term and first term to the last term. I have added 2 plus 17, 5 plus 14, 8 plus 11, 11 plus 8, 14 plus 5, 17 plus 2. What do you get? This will be a 19. What do you get? This will be a 19. And it is a 19. And 19. It is a common. Just how we got 2a plus n minus 1 into D on addition of every successive terms. 2a plus n minus 1 into D. Similarly, here reversing the order, we got the same 19, 19, 19, 19 and 19 and again it is a 19. How many terms are there? 1, 2, 3, 4, 5, 6 terms. So add 2Sn is equal to, so 1, 2, 3, 4, 5, 6, 6 into 19. 6 into what? 19. I want only Sn. Sn is equal to 6 divided by 2 into 19. 2 ones are 2 threes are 2 ones are 2 threes are, which is equal to 57. What it is? 57. This is the way how we add 2 plus 5 plus 8 plus 11 plus 14 plus 17. We get the sum which is equal to 57. 2 plus 5 is 7 plus 8 is 15. 26, 30, 40, 57. This is the way. I hope you enjoyed this, a simple and very easy technique for this explanation of arithmetic series. Now in next our video I am going to solve you some more problems which are based on the arithmetic series. One important thing, my dear viewers, please don't forget to subscribe me, because you have nothing to invest, you have nothing for the referral chain business, you have nothing for something investment in this one. Only investment is your time investment, and this time investment will definitely fetch you and it will give you back, return you back in a very standard way. So don't forget to subscribe and don't forget to share. My all friends, my fraternity and my colleagues and my students, please do remember and just share it, subscribe it and enjoy with this simple learning of mathematics. In future days to come, still we have many more things to discuss and interact with you, and will be a simple and very humble endeavor to reach you out there for making you understanding the mathematics easy. With this, I am going to take a leave from you. I hope everybody will enjoy it. Take care. Thank you. Bye bye.